So the reason we start in the ventral horn is because it has the largest neuron. Now, you're going to get to a point where you have really small neurons, and you're going to be at a point where you can't really tell the difference on a Nissl stain between a small neuron and an astroglial cell. So, for example, this right here, because of the shape of it, it looks sort of triangular. It could be a small neuron. So there's ambiguous cases as well. We go out into the white matter. Okay, this is the gray matter. If we go out into the white matter, what do we see? Well, mostly we see light stuff. And every now and then we'll see a big hole with a little dot in it. And that little dot is an axon. And the light space is where the myelin used to be, wrapping around that axon. So there's lots of big holes with little dots in it. Then you see smaller profiles like this one, where it's the same type of thing. It looks like a light area with a dot in it, but it's much smaller. So axons come in various diameters, the myelin wrapping as well as the axon itself. And so you see a variety of diameters in these profiles that are cutting cross-section. The point is, the little darker dot is the axon, and the thing that looks like a white space around it, that's where the myelin used to be before we used these chemicals and dissolved it when we prepared the slide. Now the purple dots are going to be two things. Oligodendroglial cells, like this one right here, and directly above it, an astroglial cell. So there's astroglia in the gray matter and the white matter, but of course we expect to see a lot of oligodendroglia in the white matter because they're making segments of myelin. Here's another example of an oligodendroglial cell next to an astroglial cell. Any questions about this slide?